Now let's study straight lines, which is the third chapter of coordinate geometry. What is a straight line? A straight line is line L as you see on the screen. It can extend in both the directions. But here we are going to study the equation of a straight line. Now why study the equation of a straight line? By the equation of a line, we can know the angle between the line and the x-axis. We can also know if a point lies on the line or not. We can also know by the equation whether the line is parallel to the x-axis, parallel to the y-axis, or it passes through the x-axis, passes through the y-axis, or through the origin, and so on. Now, how to form the equation of a line? To do this, we should be given a point which lies on the line and the slope of that line. Now, slope. Now, to understand the concept of slope better, let us look at this figure. Here we have the x-axis, the y-axis, and we have the line L. This line makes an angle theta with the x-axis. We take 2 points P and Q on this line. Now we want to find the slope of this line. To do this, we join P to the x-axis and Q to the x-axis. Now we complete the triangle as QPR. Now at point R, the coordinates will be x2, y1. In this triangle, angle P will be obviously theta. So in this triangle, we have the slope is the vertical rise upon horizontal, that is QR upon PR. Now what is distance QR? That is y2 minus y1, and distance PR will be x2 minus x1. So we have slope is equal to y2 minus y1 upon x2 minus x1. Now note over here, in this triangle PQR, we have the angle theta, and to theta, opposite side is QR and adjacent side is PR. So we have slope as opposite side upon adjacent side, which is tan theta. Slope can also be defined as tan theta, where theta is the angle of inclination between the line and the x-axis. Now let us look at the slope in different forms. That is, slope of x-axis is tan of 0, which will be 0. Slope of y-axis is tan 90, which is infinity. We can say it is not defined. Now if two lines are parallel, then their slopes will be equal. And if two lines are perpendicular, then the product of their slopes is -1. That is, one slope is the negative reciprocal of the other. Now what if a line is parallel to the x-axis? Then its slope will be again 0, because slope of x-axis is 0. Similarly, the slope of a line parallel to the y-axis will be not defined. Now let us take collinear points. We can say 3 points A, B and C are collinear if slope of AB is equal to slope of BC. Now we take the equation of the line finally. How can we form this equation? This can be done using 3 types. Type 1, that is slope-intercept form. When we are given the slope of the line and the y-intercept, the equation can be written as y is equal to mx plus c. Here m is the slope and c is the y-intercept. Now type 2 would be point-slope form. Here we should be given 1 point on the line and the slope of the line. We write its equation as y minus y1 is equal to m x minus x1, where x1, y1 are the coordinates of the point. Now the type 3 is 2-point form. Here we should be given 2 points, say with coordinates x1, y1 and x2, y2. Then to get the equation of the line, we first need to find the slope as y2 minus y1 upon x2 minus x1. Then we can write its equation as y minus y1 is equal to m x minus x1. Now the equation of the line will be different for different axes. Let's see that. Equation of the x-axis is y is equal to 0. Equation of y-axis will be x is equal to 0. Now equation of a line which is parallel to the x-axis at a distance a units from the x-axis will be y is equal to a. And the equation of a line parallel to the y-axis at a distance b units from the y-axis would be x is equal to b. Now let's see the prerequisites for this topic. You need to know the X intercept, that is the distance along the x-axis. The Y intercept, that is the distance along the y-axis. Coordinates of a point on the x-axis at a distance of x units from the origin are x, 0, and the coordinates of a point at a distance of y units on the y-axis are 0, y. Now keeping all this in our mind, let's start with the problems based on this topic. We start with the simpler ones. The first one, if 7, a minus 5, 2 and 3, 6 are collinear, find a. Here we are given 3 points and given that they are collinear. Let us name these 3 points as A, B and C. Now we know that if 3 points are collinear, then their slopes are equal. So we have slope of AB is equal to slope of BC. Now to find slope of AB, we have coordinates of A as 7, a and coordinates of B as minus 5, 2. Slope will be y2 minus y1 upon x2 minus x1. We write that as 2 minus a upon minus 5 minus 7. Simplify this, 2 minus a upon minus 12. Now take the other side, that is slope of BC. We have the coordinates of B as minus 5, 2 and coordinates of C as 3, 6. So their slope will be 6 minus 2 upon 3 minus of minus 5. Simplify 4 upon 8, which can be further simplified as half. So we get the equation as 2 minus a upon minus 12 is equal to half. Now cross multiply. We have 4 minus 2a is equal to minus 12. That is 16 is equal to 2a. So a is equal to 8. So we have got the value of a as 8. Now we take the next problem. Find the slope and inclination of the line AB if we are given the 2 points A and B. Now to find the slope, we'll do y2 minus y1 upon x2 minus x1. So we have 0 minus of minus root 3 upon 3 minus 0. Simplify to get root 3 upon 3. That is nothing but 1 upon root 3. So we have got slope as 1 upon root 3. Now we are also asked to find the inclination, that is the angle theta. Now we know slope is equal to tan theta. So we have tan theta is 1 upon root 3. Now tan of what angle is 1 upon root 3? We know tan 60 is 1 upon root 3. So theta is equal to 60 degrees. That is, the angle of inclination is 60 degrees. Now the second part in this, we are given again 2 points A and B. Their slope can be obtained as 2 minus of minus 2 upon 1 minus of minus 3. Simplify 2 plus 2 upon 1 plus 3, that is 4 upon 4, which is equal to 1. Now same way, tan theta is 1. Tan of what angle is 1? Tan 45 is 1. So theta is equal to 45 degrees. So in the second part, we have got slope is 1 and theta, or the angle of inclination, is 45 degrees. Now we take the next problem as, if 3y minus 2x is equal to 4 and 4y minus px is equal to 2 are perpendicular to each other, find the value of p. Now here we are given the equation of two lines and we are told they are perpendicular. Now we know that if two lines are perpendicular, then the product of their slopes is minus 1. So we need to find the slopes of these two lines. To do that, we compare this with y is equal to mx plus c. So we write the first equation as 3y is equal to 2x plus 4. That is, y is equal to 2 upon 3x plus 4 upon 3. Now, we take the equation of the second line. We again write this in the form y is equal to mx plus c. We have 4y is equal to px plus 2. That is, y is equal to p upon 4x plus 2 upon 4. So, the slope of the second line is p upon 4. Now, they are perpendicular lines. So, the product of their slopes is minus 1. That is, 2 upon 3 into p upon 4 is equal to minus 1. We simplify and get p upon 6 is equal to minus 1. That is, p is equal to minus 6. Our next problem, given that the line y upon 2 is equal to x minus p and the line ax plus 5 is equal to 3y are parallel, find the value of a. Here again we are given the equations of two lines, but we are told that the lines are parallel. And we know that if two lines are parallel, then their slopes are equal. So same way we are going to find out the slopes for the two lines and then equate them, because here the slopes will be equal. Now compare them with y is equal to mx plus c. We first write in that form. First equation can be written as y is equal to 2x minus 2p. So we have slope as 2. Now for the second equation, we write y is equal to a upon 3 of x plus 5 upon 3. So the second equation slope is a upon 3. Now they are parallel, we equate them to get 2 is equal to a upon 3, that is a is equal to 6. Now we look at our next problem. Write down the gradient and intercepts on the axis of the following lines. Now the first equation for us is x by 3 plus y by 4 is equal to 1. Now we will again write this in the form y is equal to mx plus c. So we write this as, first take the LCM, we have 12. So the equation becomes 4x plus 3y is equal to 12. That is 3y is equal to minus 4x plus 12. So y is equal to minus 4 by 3 of x plus 12 upon 3. We simplify further. Y is equal to minus 4 upon 3x plus 4. Now we compare this with y is equal to mx plus c. We have the slope m is minus 4 by 3 and the y-intercept is c, which is 4 over here. Now we are also asked to find the x-intercept. To find that, we will substitute y as 0 in the equation of the line. We have x by 3 plus 0 is equal to 1. That is, x is equal to 3. So in the first part, we have the slope is minus 4 by 3, x-intercept is 3 and the y-intercept is 4. Now we take the second part. Here we are given the equation as 3y plus 2x is equal to 12. We write this in the form y is equal to mx plus c. We have 3y is equal to minus 2x plus 12. That is y is equal to minus 2 by 3 of x plus 12 by 3, which can be simplified further as y is equal to minus 2 by 3 of x plus 4. Now we compare this with y is equal to mx plus c. We get m, that is the slope, as minus 2 by 3, and here c is equal to 4, that is the y-intercept is 4. Now to get the x-intercept, we substitute y as 0 in the equation of the line. We have 3 into 0 plus 2x is equal to 12. That is, 2x is 12, so x is 6. So here we have the slope as minus 2 by 3, the x-intercept as 6, and the y-intercept as 4.